Hello everyone, welcome back to the channel Code with Abby. In this session, we are going to talk about one of the important topics in SQL Server called as UDF, that is user-defined function. Imagine writing a piece of logic once and reusing it across dozens of queries, saving time, reducing errors, and keeping your code clean. That's the power of user-defined function in SQL Server. Did you know that SQL Server 2019 brought a game-changing update, scalar UDF inlining, that can make your slower queries run up to 20 times faster? Yes, that's right. Functions aren't just for reusability anymore. They are a hidden performance booster too. In this video, we are diving deep into what user-defined functions are, why they matter in real-world SQL development, when and where you should use them, and how to create and apply them like a pro. Whether you are a beginner looking to structure your SQL code better or a seasoned developer chasing optimization, this video will be your practical guide to master UDF with real examples and must-know tips. If you find this kind of content valuable, please take a moment to subscribe, like, and share this video. This really helps us create more quality content just for you. Let's get started and unlock the power of SQL Server functions. Let's first define what user-defined functions are. User-defined functions in SQL Server are routines that accepts parameters, perform actions on that. The actions can be calculations, manipulations, etc., and then return a result. They're like functions in other programming languages. So if you are having any programming language background, you might have written functions or methods. So why you write that particular thing? So you write function or method to segregate your code so that a piece of code can be written and can be given a particular name. And whenever you need that particular set of code to be executed, you simply call that name and then whole lot of codes will get executed. Like that, if you have some business logic and you want to encapsulate that business logic and give a name so that you'll have a kind of abstraction there, and then you can use that name in your logics or wherever you want to use it. Like that, we have user-defined functions or UDFs in SQL Server. I'm going to show you the first glimpse of UDF, user-defined function in SQL Server Management Studio. This will give you a little idea on how they look and where they stay there in SQL Server Management Studio's database hierarchy. I am in SQL Server Management Studio, and to demo the topics today, let's go to create a couple of tables. I'm going to create the first table called TVL employees, which has got 5 fields: employee ID, employee name, DOB, email, and salary. And there are the types and some constants there. You already are aware of these things. Let's go select and create this table. Table has been created. Let's go and insert a couple of records to the table. We have seen that records have been inserted. And let's go and see the content in the table. We are selecting it, and you see that there are 5 employees. They are having their names, DOB, email, and salary. What is the requirement? The requirement is I'm going to need some logic which will calculate the age of each employee, because the company or organization wants to do some activity based on the age calculated. So how can we do? Either we can write a logic here in the query, or you can actually delegate that whole logic to a particular routine name or a function name. So let's go and create a function. This function is getAge function, self-explanatory. It will calculate or give you the age of the person, and it will take date of birth as a parameter. I'm going to explain this logic in a moment so that you will be clear about how to create functions, but just focus a little. This function takes a date of birth here, and it calculates years in age. Let me go and select this to create this. This has been created, and now let's go and execute the query. The query has been executed, and you see the result. It shows the employee ID, employee name, date of birth, and the respective age in years of that particular employee. This is the syntax of creating UDF. In order to create a UDF, you have to write create and then function. Function is a keyword, function, and here you have to write the schema name. So usually the schema name is database owner, DBO. So here the schema name, and then the function name. In our case, the function name is fn getAge. fn is a prefix that we usually give in order to segregate as this function. It is the function, okay, and this is a parameter value that you accept it. So this is the parameter name and data type. So in our case, the parameter name is dob and the data type is date. And here what you have to write, returns what kind of value this function returns. So in our case, this function returns integer type of value. Make sense? And then as begin and end. So every logic of the function goes between this begin and end. I assume that you already are aware of how can we write functions and the syntax about functions. Let's go and try to see some real-time use cases or real-time uses of user-defined function. The first use is HR department or HR system in any organization want to display the age of employee or tenure in the company. So tenure is how many years that employee has served the organization. So that is the tenure of that employee in that organization. So this is a simple use case. They can write the whole business logic under a name and they can give a name. In our case, it was get age, and then they can write the whole logic there. So in this case, we can use functions. We have already seen this example. The second case is standard date formatting. An organization had a dashboard, and that dashboard requires date to be shown in DD, MM, YY format. So usually dates are stored in default format. So let's see that date of birth here has been stored in default format, where that YY and then MM and then DD and then hour, minute, seconds, milliseconds, like that. We want to display the date in this formatted like 9/5/1998. So what we can do, this logic of calculating standard formatting can be given to a function. We can create a user-defined function for the same, and we can give a name, and then we can utilize that function in our code or wherever we want to utilize this. Make sense? Let's go and see this function as well. So here I am going to create a function. The function name is format date, and this format date function takes one date and then it formats in that way. Make sense? So let's go and create this function. So you know the logic that you know the syntax that we have already discussed. It is checking the existence of the database object. If you have seen my videos, I have been introducing this to check if this particular database object already exists, then drop it and then create a new database object. So this way you can create a function. The function has been created, and in body you see that I'm going to format this function. Make sense? We can also see that where is this function sitting. So we are in CWAD demo. So we can go to explore the CWAA demo, and then we can see one place is called programmability. So I am here, and then I see that going to programmability, and then in functions we can go and we can check that function in scalar functions. You can see this function which we have just created, format date, right? So this way you can verify your function has been created and where have they been created. So having said that this function has been created, let's go to execute this function, and we are hitting this button. Let's go. So we are giving this date of birth to this function, which will format the date of birth in our expected format and give it back. So you can see that one Sumit Kumar has date of birth in this format, but we wanted this to be written in this format, that is DD, MM, YY, and it has written in that format. Make sense? The next real-time use is consistent tax discount. So we have some business logic for consistent tax discount for many orders or for, let's say, purchases. So for that business logic can be written in a function, in a user-defined function, and that can be utilized. This is a function that we have created, which is called as apply tax, for which we will create one table. So this table is TBL product to show you in a demo, and this has got some values. So this is a TBL product. Values have been inserted. Let's go and select all from TBL product, and then selecting it and hitting this, we have this data in TBL product. Now we want to calculate the tax on this. So simple, we are taking input as many parameters here. We are taking amount as parameter input, rate as parameter input, and we are returning value of decimal. So what we are returning, we are calculating the tax here, and then we are returning that. Let's go and create this function again. The function has been created, and then execute the function here. So you can see that final price tax calculated out here. Make sense? Next example in the series is check business hours. So basically there is a customer support system. In any organization there are customer support system, and they need to verify if a sensitive request came to them within the hours or not. So what happens, these teams operate in certain hours of the day. Let's say they are operating between 9 a.m. to 5 p.m. and if any request come beyond this limit, they should refuse it. So in that case, they can actually delegate that whole section to check whether this currently is a business hour or not. They can create a user-defined function, and you can use that user-defined function to check the business hours, and based on that they can take decisions. Make sense? So let's go and see this. So here I am where I'm going to create a function called isBusinessHour. IsBusinessHour is a function which takes the current date or the date that you supply, and which will give you the information in 0 or 1. If it is weekday, then it will give you 1, otherwise it will give you 0. Make sense? So how it checks is, it checks that if a time that you have provided is in between 9 to 5, and if the weekday is not in Saturday and Sunday. So if your request has come between 9 to 5, which is business hour, and not on Saturday and Sunday, then it will return 1, that is true. Based on that, you can take the decision. You can write code here and you can do whatever you want. Let's go and create this. And in this function, we will supply the current date here. So the current date right now is 10 a.m, 10:20 a.m. That means it is business hour. And then it is Sunday, then it should give me 0 here because it's not the business day. It's not the weekday, it is weekend. So let's see, it gives me 0. If you execute the same function on Monday, at the same time, it will give you 1 here, based on which company may decide or may perform some other activities. The next real-time example is category-based labeling. So company wants to classify the tier of their users or purchases or customers. So based on how much they do shopping or purchasing, based on their purchase amount, they can label them as a silver or a gold or a silver or a bronze or whatever that way. So this involves lots of business logic. So instead of doing this in the query, they can delegate this whole business logic and they can give a name. So this way they can create a user-defined function for the same. I'm going to show you that how companies can use business logic to be there in the user-defined function to label the customer. So we are going to create 2 tables, the order table, which has got item ID, item name, purchase, and customer name. Let's execute this, insert the records, and then create the function. So what function does is, it takes the total purchase as a parameter, and based on that, it calculates if the purchase is more than 10,000, then that customer falls in gold categories. If that purchase is greater than 8,000, then it is silver category, and else bronze categories. So this way we can create, you can actually enhance or increase or write the business logic based on the requirement. This is just to demo. And then if we are going to select this, you see that it shows that Sumit Kumar is silver. So let's go and try to see the types of user-defined function. There are 3 categories. The first is scalar user-defined function. The second is inline table valued function, which we also call as IV ITVF, and we have multi-statement table valued user defined function. We call it as MTVF. The first is a scalar function. This kind of functions which returns a scalar value, a single value, that is called a scalar function. We have already seen this example. The second is inline table valued function. This kind of user defined functions actually have some SQL query. Based on that, they return a result in table format. So there is a variable called table. So table is just a table for it's just a kind of a data type, which is a table data type. This actually returns the whole row set from these, and this has no begin and end, and single select statement involved. So we will go and see this. So here I am, and I'm going to create one function called get employees older than age provided. So we'll provide the age, and it will display us or give us those employees who are older than the age we have provided. So this is a single valued, inline single valued function here, where you can see that single select statement. So whatever age that we supply, it checks with the age that customer's date of birth year is greater than the age that we supply. If it is, then it returns that value. Let's go and create this. So create it, and then let's go and see how many employees are there who are older than 25 years. So these are the employees. Likewise, you can change this value. You can change this 20 year, and you can see there are many. You can check with 30 years, and you can see they are one. So this way you can use this. The next type of function is multi-statement table valued user defined function, which we also call as MTVF. This function involves multiple select statement. You see, this is the select statement where we have put joins also, right? And based on these calculations, so this does lots of calculations, and based on this it returns some value. So we are returning total purchase value. So we are preparing data. So you see that we have created a table variable here, and in which we are creating this three type of fields. So this way you can create. I will explain the table variable concept when I will explain common table expression in future. For now, you just try to understand that we can create a special type of variable called table variable, wherein you can actually hold multiple values. It's a kind of tuple. I mean, you have one row and multiple columns, or multiple row, multiple columns. It's like a table set. So here we are doing a lots of calculations, and we are inserting into this, and then we are returning. So you know that begin and end here. So in multi-statement table valued, there is a begin and end involved, and there are multiple select statement. They can be combined together using join or other relationships, and here is the result. So for this, we are creating couple of tables. The first table that we are creating is customer table, which is having customer name and customer ID. Let's go and create this. This has been created. Let's insert this value to this, insert it, and then we are creating one more table is called orders, which will have orders. So these customers will be placing orders. So orders have been created. Let's insert some value to the order table. Both the tables have now values. Let's display those values. So you see this is customer table and the orders tables below. Make sense? Now let's go to create this function. As usual, this function takes one input, that is called minimum purchase amount. This accepts one parameter, minimum purchase amount, and which returns this particular value. So it prepares a table variable here which has three fields, and it returns the particular row set from here. In this, we are joining these tables, customers and orders tables, and we check whosoever purchase amount is more than amount, then it returns that value. Make sense? Let's go and select this and create this function. The function has been created. Now let's go and execute this. So this is the way that we are going to execute this function. So we are supplying 3000. So this will give you all those customers details who actually have made purchases at least of $3,000. So if I'm making it 2000, so it should give a different result. minimum of 2000, right? So if I'm saying minimum of 4000, so it will give you less record because one guy has gone who purchased 3000. Make sense? Why to use UDF? The first is code reusability. We have seen that we have written the code at one place and we are using it many places. So use once, write once and use many times. Simplify the complex logic. So you have complex logic, you have lots of calculations, you have lots of business logics. You can delegate to a name that is called function, and you can hide the complex calculation or business rules. Maintainability, it is easier to manage because you have written it at one place, but you are going to utilize it at 100 places. So if any changes needs to take place, you have to change at one place only. You did not go to all those 100 places and do the changes. And modularity, obviously it breaks down the queries into manageable pieces. So modularities. I understand the concept of user-defined function, which I have explained to you, their uses, the use cases, and the real-time use scenarios, all pretty much clear to you. If you found this video helpful, don't forget to hit that like button and subscribe for more high-quality technical content. Drop your question in comment and I will be happy to answer them. See you in the next one. Bye-bye.